Okay, families, so this is the beginning of the homework for the evening. Number 9, Jerry uses 50 pounds of milk to make 5 pounds of cheddar cheese. Now, we're going to learn later that it's going to be important to list the dependent and independent variable in order. The independent first and then the dependent later. So it's the cheese that is going to make the milk. So we're going to list the cheese first in our table. So here's the data that we need to use. Right here, it's in picture form. It's going to take 50 pounds of milk. It's kind of odd that they would show 6 gallons. So I'm guessing somehow 6 gallons comes up to 50 pounds. And to make 5 pounds of cheddar cheese. So I guess our data really isn't there. It's more right here. So we're going to be comparing milk to pounds of cheese. Milk's going to go in and it's going to cause pounds of cheese to come out. So we're going to list milk first in our rate table. Okay, this is a table. Some of the students are calling it a graph. It is not a graph, it's a table. We are going to be graphing here soon, but it's just not now. So, excuse me. So it is milk that's going to cause cheese. So we're going to have 50 gallons of milk. And that is going to make 5 pounds of cheese. And before we make our table, we're going to have to make the table, if I remember right, it is going to be starting at pounds of cheese, starting at 5, going in intervals of 5 until we get to 50. So we're going to go ahead and start with our cheese here. And we're going to continue this out, starting from 5, going at intervals of 5 until 50. So here, hopefully your students recognize the relationship between the gallons of milk needed for the pounds of cheese. We're at a 1 to 10 ratio, right? If we were to reduce this down. So basically, we're going to take our pounds of cheese and multiply it times 10. Or 15, 20, 25, 30, 35, 40, 45, and then we have 50 up here. And or we could just count up by 50s or multiply by 10, either one we're good. So we're 100, 150, 200, 250, 300, 350, 400, 450, and then 500. With that, we're done with 9A, I believe, 9A. We just needed to make a rate table. Let's go ahead and check that out. Oh, that's not going to be awesome. Yep, that's all we had to do for part 8. 9A is make this rate table. And we have our rate table. So your student's rate table should look like that. Then we're going to go ahead and move on to 9C. I had students skip B because B is graphing and we haven't gotten to graphing quite yet. C, we're going to write an equation relating pounds of milk, M, to pounds of cheddar cheese, C. So we're going to relate M to C. Clear annotations. So for 9C, we are going to relate pounds of milk to pounds of cheddar cheese. The ratio we've been given right now is 50 pounds of milk to 5 pounds of cheddar cheese. And now we're going to go ahead and rewrite this. So we're going to rewrite this as a fraction, 50 pounds of milk to 5 pounds of cheddar cheese. Now, if we're going to find a rate for this, we're going to find for 1 pound of cheddar cheese, how many, oops, I guess that should be lowercase, how many pounds of milk? So we're going to divide both by 5, and we discovered this already, that this ratio reduces to 10. Oh, goodness, how do I say 10 and write 15? 10 pounds of milk per 1 pound of cheddar cheese. So that takes care of the rate that we need. Now we need to write an equation. So if I want to know how much milk I need if I need to know how much milk I need to take my rate of 10 gallons of milk per pound of cheddar cheese, and I need to multiply that times, I'm going to go ahead and put parentheses around that to make it easier, times the cheese or pounds of cheese that I would like to make. So if I want to make 1 pound of cheese, I multiply 1 times 10, and I will have my pounds of milk. I need 10 pounds of milk. Now, we're going to find out that if that sequence doesn't logically make sense to you, it's once we find our rate, whatever's in the denominator is going to cancel out when we multiply it times our variable here. So if C is in the denominator and we multiply straight across, our units C are going to end up in the numerator, and we're going to be left with just milk. So that's one way to think about it. Whatever's in the denominator is likely the variable that you are multiplying by. The other is just to think about it. I don't mean this condescendingly. Think about it logically, to try to logically step through it and say, what am I multiplying by 10? What is the larger of the two numbers? If I'm looking here, I'm multiplying my cheese times 10. Therefore, cheese has to be next to the multiple of 10. If we had found a different rate, let's say we had found the rate of cheese per gallon of milk, we would have discovered that it is 1/10 of a pound of cheese is created with 1 pound of milk, and we would have to multiply that times m to go ahead and find our cheese. So if we only had 1 pound of milk, we're only going to be able to make 1/10 of a pound of cheese. And that makes sense because we need a lot of milk to make a little bit of cheese. So if we only have 1 pound of milk, we're only going to make a very little bit of cheese, which is 1/10 of a pound of cheese. So if your student has this work as their answer, that is fantastic. This is the equation we're looking for. This is the work that gets us to that equation. And this right here is our rate, or also known as our constant of proportionality. It's a more complicated way of saying that we're keeping things proportional at a constant rate for the entire spread of possible inputs. So that is 9C. Last part of 9 is line 9D. 9D asks us, what is the constant of proportionality from your equation in part C? And I just answered that. So the constant of proportionality for 9D, depending on how your student found it, is either 10 pounds of milk per 1 pound of cheese, or they may have found 1/10 of a pound of cheese per 1 pound of milk. So you would end up with 1/10 of a pound of cheese for every pound of milk, or here you need 10 pounds of milk to create 1 pound of cheese. So that is our rate of proportionality for 9D. It's going to be one of those two, depending on the equation that your student found. So the last part of the homework is number 10. Let's go ahead and pull that in. So number 10. Number 10 is a long one, but the parts are quick. So let's go ahead and bring this in the page. There we go. So number 10, Keely buys songs from a music website, and she buys 35 songs for $26.25. The math on this is going to be a little bit difficult. Regina gets a $50 gift card for the music site. She tries to estimate how many songs she can buy with the gift card. Which estimate is reasonable? Explain. So it appears that she can buy 35 songs for $26. So the songs are cheaper than $1 per song. Because if she was paying $1 per song, $26.25 would buy 26 and a quarter songs. But we get 35. So we're going to be able to get more than $50 worth of songs, 50 songs, excuse me. We're going to be able to get more than 50 songs for 50 bucks. And then if we look at how much more, this is about 10 more songs than the dollars that we have. So I'm guessing each song is going to be somewhere around 70 cents a song. So let's go ahead and take 50. Let's go between 30 and 50 songs. This can't be it. We definitely get more than 50 songs. I don't think we get nearly twice as many songs. So I'm going to say that we get around 70 songs. Sounds reasonable, but more than 70 songs. Interesting. Now, I think what they're asking us to do is to compare these two prices here. So I have a little less than twice as much money. So I get a little less than twice as many as 35 songs. Does that make sense? So we're creating a ratio here of price to songs. I have a little bit less than double the price here. So I'm going to get a little bit less than double the 35 songs. So that is going to be that answer there. And you're going to look for some sort of explanation for that. The best your student can do, give me a sentence or two of showing how they compared the $50 gift card to the original $26 and the question amount of songs to the 35 that they would have received with the $26. And I'm good. If they can't explain it in words, if they show me a word, something worked out, some ratios, that would be fine too. Copy and complete the table below. We're doing exactly that. So here I need to find out my cost per song. So if I want to find my cost per song, I am going to take my total costs, my total cost here, right here. And I'm going to write 26.25. This is my cost. I'm going to divide that by my number of songs, 35. This is my number of songs. And that is going to give me my cost per one song. So I'm going to take this and put it into a calculator. Math tools, calculator. And I was pretty close with my estimate. We're at 75 cents a song. So now that I know that each song costs 75 cents, it is much easier to calculate all of these other prices. Our strategy up to this point, before we started using equations and rates, was to try to use parts of the table. So I would have to figure out what portion 50 is of 35. So I might divide by 7, that gives me 5, and then multiply by 10. And then that would tell me how many, what my cost would be here, how many dollars it would cost to buy 50 songs. But now that we have a rate, now that we have this value to use, I just simply, this is 75 cents. So my apologies, I need that decimal there. I just need to multiply 75 cents times 50 songs. So we're going to bring that calculator back. Here, I'm going to take my 50 songs, I'm going to multiply it times 0.75, and I get $37.50. Yep, $37.50. So 37.50. All right, now if I want to know how many songs I get for $3, that's going to be a little bit more difficult. So we're going to come back to that here in a second. I've got 70 songs. I'm going to go ahead and handle that. 70 songs times 0.75, $52.50. Okay. Now we're going to figure out the rest. So now I need to figure out how many songs I get per dollar. So to figure out how many songs I get per dollar, I'm going to go ahead and take 35 songs and divide it by the number of dollars that it costs for those 35 songs. That's going to give me my songs per dollar. These are dollars, these are songs. So we take 35 songs, divide it by 26.25, and I get 1 1/3 songs per dollar. I get 1 1/3 songs per dollar. So if I take that 1 1/3 times 3, 1/3 of 3 is 1, excuse me. And then if I multiply it by 1 1/3, that gives me 3 and 1. So that gives me 4 songs for $3. Now I can double check that. I can say, well, I know there's 75 cents a song. So can't I take $4 times 75 cents and make sure that I get 3? Absolutely, yes, you can. Yes, you can. So here I get 1 1/3 songs for the dollars that I spend. So if I spend $15, I'm going to get 15 songs plus 1/3 of 15, which is 5. That's going to give me 20 songs here. Now I'm going to double check. I'm going to take 20, multiply that times 0.75, because that's how much it costs per song. And I'm going to make sure that that gets me $15. All right. So now we have our table filled out for C. Now we're looking at D. And I think question 10 ends with D. Yes, it does. Awesome. Question D says, Lucas and Javier discuss how to write an equation relating price to number of songs. Lucas writes the equation N equals 0.75 times C. Javier writes the equation C equals 0.75 times N. Do you agree with Lucas or Javier? Use your information from part A and C to explain. We, of course, are going to agree with Javier. Javier is taking the price per song and multiplying it times the number of songs in order to find the total cost. Because 75 cents, if you remember from our previous calculations, related the price per song. And when we take that, actually, let's use the variables that they're using in the equation. That would be more appropriate. 75 cents, that's the cost per song. And we're going to take that and multiply it by the number of songs. All right? We can prove that with our data table. We can prove that with our work with the ratios. You can prove that in multiple ways, but we are definitely going to agree with Javier because his equation is the correct one. All right, so hopefully that helps with the homework and your student got most of those answers right before they watched the video, or the video helped them understand what the questions were in the first place. Thank you so much for taking the time to watch the video. Have a great evening.